Alright, this is Daniel. I'm back, and you haven't given up. I like it. In this video, we're going to talk about anonymous classes. I am going to start this lecture with a bit of a shock. So, I'm going to define a trait called animal, and with a method def_eat, which returns unit. Or let's just say this is an abstract class. It doesn't really matter all that much. We only care that animal is an abstract data type. And here, I'm going to define a value called funny animal, which is an animal. And watch what I'm writing. I'm going to say new animal, and inside I'm going to override def_eat, and inside I'm going to print line ha. So what we did here is exactly what it looks like. We instantiated an abstract class. Shocker. Only that it's not an actual abstract class that we instantiated. We instantiated a real class. So let's prove that. So if I try to print funnyAnimal.getClass, this guy will print something. So it will say class lectures part 2 OP anonymous classes $anon $1. So what actually happened when we wrote this is that the compiler took this part right here, the animal with the curly braces, and actually created a class with a funny name like lectures part 2 OP anonymous classes $anon $1. And actually instantiated that later and assigned that to funny animal. This is called an anonymous class. So when we write new animal with a on-the-spot implementation, what the compiler actually does is basically cutting this out, saying class anonymous classes $anon $1 extends animal, and then with that little implementation that I provided. And when I use it, the compiler actually instantiates that class instead. So this is what actually happens when I instantiate an anonymous class. So when we said funny animal equals new animal with that on-the-spot implementation, what actually happens is, and I'm going to put this in the comment section so that it's easier to refer to. So equivalent with class anonymous class is $1 extends animal, and then val funny animal, which is an animal, is in fact a new this guy. So the compiler does this behind the scenes. Now, if I define, let's consider a class person with a name. Okay. And with a method called sayHi, which returns unit and just prints something to the console saying, for example, with an X interpolated string, hi, my name is name, how can I help? Something like that. Now, if you wanted to use an anonymous class for person and pass that to a value, say Jim is a new person, and following the scheme from animal, supply some on-the-spot implementations, like for example the sayHi. If I copy this around and override this and saying hi, my name is Jim, how can I be of service? All right, this thing would work fine if it weren't for the parameters for the person class. So just as it was illegal to extend the class person without supplying the proper parameters, it is as illegal here to instantiate an anonymous class here, because the derivation or the extension of the class already happens under the hood. So make sure you pass in the proper parameters. So let's say we have the person with a parameter Jim. So be a good student and pass in the proper parameters for the superclasses that you are extending, even anonymously. Another rule that I didn't really mention, but I think is common sense is to make sure you provide implementations for all the abstract fields or methods in the abstract types or traits that you instantiate anonymously. Otherwise, the compiler wouldn't be able to create a non-abstract class in the back for you. But notice here that this anonymous class works for the class person even though person is not abstract in any way. So anonymous classes work for abstract and non-abstract data types just as well. Alright, so let's wrap this up. We learned that we can instantiate types and override methods or fields on the spot. So if, for example, I have a trait with an abstract method definition, I can actually instantiate that trait and provide a definition on the spot. There are only two things that you need to take into account. So first of all, you need to pass in the required constructor arguments if you're extending a class and if you need to. The second is that if you are instantiating an anonymous class which descends from an abstract data type, like an abstract class or a trait, you need to implement all abstract methods or fields. Also, just to know, anonymous classes work for traits and classes, whether they're abstract or not. Alright, so this was a shorter one, but I'm waiting for you in the next video where we are going to expand my list with some generic predicates and transformers and also anonymous classes. I'll see you there.